look at solving a pair of simultaneous equations using the matrix method. To begin with, we want to create three matrices from the pair of simultaneous equations, and I'm going to name them A, which will be the coefficients of x and y, right? Important to always capture your signs, right? So we're going to get here 4, 3, -5, and +2, right? The other matrix is going to be the variables, which is x and y, and then we have our, let's call this one here k. These are the solutions, not the solutions, but the answers on the right hand side of the equal sign. So these are the three matrices. Now, if we think about this, currently we have A, which is the coefficients multiplied by x, giving us k. In algebra, if we carry the A across the equal sign, we will divide, but we already know we can't divide matrices. So when we move this A over the equal sign to solve for x, it will become A inverse multiplied by k. So to solve for x and y, what we're really doing is taking the inverse of A and multiplying it by k, right? Now let's write those matrices and see what it looks like. So I'll begin one time by putting x and y here, right? Now this should give you some kind of indication that the answer you're going to get will be a 2 by 1 matrix, meaning that you're going to have 2 rows by 1 column. And we know that is true because when I multiply a 2 by 2 by a 2 by 1, the middle numbers is showing that it's compatible. The end numbers is going to tell us the answer we're going to get, right? So I'm scrolling up a little bit here. So what's going to happen is we should have a matrix that is made up of 2 rows, right, and 1 column. That's what should happen in the long run, right? But this 4 -5 and 3 is A, and what we need is A inverse. So we need to find the A inverse and then multiply that answer by k. Now to find the inverse of a matrix, we will take 1 over the determinant, which is AD minus BC, multiplied by the adjoint, right, which is going to be DA minus B and minus C, and then multiply that by k, right, which is our -6 and 7. So we could say here, let A be our matrix, which is equal to the A, B, C, and D. So we could easily look here and see what values we're going to be plugging in. So I get 1 over A is 4, D is 2. Remember to use your brackets because B is already -5 and C is 3. And then we're doing the adjoint. The adjoint is going to be 2, 4. I try to keep it doing the diagonals first. And then -5. Important, right? Minus sign here, and this is also a -5, so I need to put that in brackets. -3. So we'll work out that, and then after we get the answer for here, we'll multiply it by -6, 7. So I'm not really dealing with the -6, 7 right now. We're going to concentrate on working out the square bracket. So things that I'm not using, we'll just bring it down for now, right? So we're working out here. So 4 2s are 8, and -5 by 3 is giving me a -15. Could resolve this here. This will give me a +5, a -3, and a 4. We could simplify further again. So we have x, y. Not using these things, so I like to write them one time, so no confusion as to what we're doing. 8 plus 15 now, negative and negative is a positive, by 2, -3, 5, 4, right? line by line, step by step, right? No room for errors because I'm working out everything here on the paper. I'm not doing anything in my head. 8 and 15 would give more 23 by 2, negative 3, 5, 4. And we have our negative 6, 7 on this side, right? So far we didn't really do anything other than find the inverse, right? So now we're going to multiply each of these numbers inside of the matrix by 1 over 23. The nice thing about this is because 1 is the multiplicative identity, I will just be putting 2 over 23, negative 3 over 23, 5 over 23, and 4 over 23, right? Because we have 1 multiplying by each of them. And now we have to multiply by negative 6, 7, right? So remember, we have a 2 by 2 by 2 by 1. Our answer is going to be made up of 2 rows. I like to identify what my answer is going to look like up front, and 1 column. So to get the value that is going to come here, I have to multiply row 1 by column 1. So I'm doing row 1 by column 1. So what will I get? I'll get 2 over 23, right, multiply by negative 6 over 1, bit over 1, plus 5 over 23 multiplied by 7. That's row 1 by column 1. Then next I'm going to do row 2 by column 1. Row 2 by column 1. So I'm going to get negative 3 over 23 multiplied by negative 6 over 1 plus 4 over 23 multiplied by 7 over 1. Right? Now we just need to multiply those out, add them together, work it out, and we get our answer. So 2 by negative 6 will give us negative 12 over 23 plus 5 by 7 is 35 over 23. Alright, that's top row, first column. Underneath here, I get a positive 18 over 23 plus 4 by 7 is 28 over 23. Add those two together, what are we going to get? This should give more 2 from 5 will give more 3, 1 from 3 will give more 2, 23 over 23, and then underneath 30 and 16 is 46 over 23, and we could reduce these quite easily. We're going to get x, y is equal to 1 and 2. So our answer, or the solution, is x is equal to 1 and y is equal to 2. And this is how we would solve our simultaneous equations using a matrix method. So to recap, most importantly, I think this is the key to framing your answer. Identifying three matrices made up of your coefficients of x and y. That's our A matrix. X is our variables x and y, and k, I guess you could call these our constants, negative 6 and 7. Understanding that it is the product of ax is given us k. When we multiply these things by our variables, we get in these constants, negative 6 and 7. So we use this concept to carry the A across to get A inverse. So ideally, to solve the simultaneous equation, what we are doing is multiplying the inverse of the coefficients by the constants. Right? Remember your formula for inverse. I like to plug it in here one time instead of working it out separately. And we could come down line by line by line. Remember, the first couple of lines and the first 4 lines involves us just working out what the inverse is. Only when we get the inverse, then we multiply. Remember, this here is the format of our answer. It's going to be made up of 2 rows and 1 column. So we multiply in row 1 by column 1 to get our top value, row 2 by column 1 to get our bottom value. Alright, and our answer is going to be x is equal to 1, y is equal to 2. Alright, hope you find us helpful.